if I said I had a mean and standard deviation, let's say I had a mean of 14, standard deviation of 3. Okay. If this is my values, here I'm just going to think of a curve here. I'm going to say 14 right in the middle, that's my mean. If I go 1 standard deviation on both sides, I'm going to be at 17 and 11. Now, Chebyshev's theorem doesn't work with this 1 standard deviation. I can do 1.5, but I can't do 1. So I'm going to go 2 standard deviations. I'm going to go another standard deviation out. I'm going to be at 20. I'm going to be at 8. Now, what Chebyshev's theorem says is this. If I looked at all my data sets, let's say I had 100 values, 75% of them approximately will be between 8 and 20. That's what this rule says. 75% are going to be within 2 standard deviations. So they're within 8 and 20 on this range. Now, if I go 3 standard deviations, you'll notice it gets 8/9, which is approximately 89%. So if I went one more value, one more standard deviation out, so I went to 23, went down to 5, between 5 and 23, 89% of my values are going to be doing that. And then one more, you notice that 4, if you keep going, 4 is 93.75. And so you could be out to 26 and 2, you know. That's how many values will fall within that range of values. Okay. The further out you get, the higher percentage of values should fall, right? Now, like I said, in Chebyshev's theorem, you can go 1.5. 1.5 standard deviations would be 15.5 and 12.5. It would be between those. You can do that on this rule. Now, the difference between this is, like I said, this deals with non-bell-shaped curves. It deals with any data. Now, if you look at the other rule, and I'll come back to Chebyshev's in a second here, and that's an example here, you can look at 2 standard deviations and 3. This is a non-bell-shaped curve. Hang on. Let's get up here. If I can get up here. Okay, now the empirical rule are always, there's no formula. This is the rule. 1 standard deviation away from the mean is 68%. That doesn't change. 2 standard deviations is 95, and 3 standard deviations is 99.7. Now, every book's different. I've read this rule as the 68, 95, 99 rule. When I was going to school, it was 99. Last year, when I used the earlier version of the book, it was 99.9. This year, it's 99.7. That last number changes, I guess, every year. So it's 68, 95, 99. When it's bell-shaped, and I guess I'm going to have a graph here, you'll notice that more of the values are in the middle. So if your mean's right down the middle, 1 standard deviation, 68% of your values are going to be there. 2 standard deviations, 95. 3 standard deviations, 99. Now, what would you call a value that's more than 3 standard deviations away? You'd think it's an outlier, but there is, remember having an outlier back in 8th grade and 7th grade math? There is actually a formula to determine if it's outlier or not. It has to be significantly far enough out to be an outlier.
How do you determine that?
Like I said, this is sort of there's a formula. Everything has a formula as you go in here. So we'll get to that. But so this rule, if I'm going to use the empirical rule, unless they tell you to use it, one of the things we'll learn later on is you cannot use the empirical rule unless you know your data is approximately normal. If it's not normal, you have to use Chebyshev's theorem. So that's kind of where you have to look at, because otherwise the rules don't follow. If the rules are a little bit skewed, it doesn't work.
What was the formula for that other one?
1 minus 1 over k squared is Chebyshev's.
So what are you supposed to do with Chebyshev's if you have only 1 standard deviation? You're supposed to measure.
You don't use it. You can't use it.
So like for the one, like the fun concepts, you can't use it.
Oh, but since you just say you might have to go 1.1, you're trying to get, you're going to get real close to it, but you might be a little bit further off. Okay. Let's look at one in the book now. I don't like using the ones on the board here. Let's go to your book and let's do a Chebyshev's and rule here. So we're on chapter 3. Look at 38 on page 131. Actually, I'm gonna do 30. Did you do 39 homework?
37.
37. I'll do that.
Actually, I'm gonna do 39 or 40 because.
So which
which
one?
one was it on the test? The average number of trials it took for a sample of mice to learn a traverse maze, to learn to traverse maze was 12. Standard deviation was 3. Use Chabachoff's theorem to find the minimum percentage of data values that will fall within the range of 4 or 20. So in other words, if you think about this, it says right now, my mean is 12. And standard deviation was what? 3. So if I start going here, I got 3 here, would be 15. Here is 18. Go on this side, 9, 6, correct? And how much further would we go?
2/3 of another.
Another 2/3 of another one. We can see if there's a different way they want us to do this one real quick. And both sides, actually, you're gonna go, if we went 3 more standard deviations on both sides, this would be 21, this would be 3, but we don't wanna go all that way. We wanna be from 4 to 20, right? So now if you think about it, we have 2 more on both sides to go. 2 out of the 3 that you could go, right? So how many standard deviations are we away from the mean? 2 and 2/3, okay, 2 and 2/3. Now, if you, it says use Chebyshev's theorem to figure out what percentage, or this is Chebyshev's theorem. So what we're gonna do here is go on our formula, how many standard deviations? So we're gonna have 1 divided by 2 and 2/3 squared. Work that out to get a decimal. Okay. So we got 1 over 2 and 2/3 squared.
1 minus that.
And I end up with a decimal of 0.8594. I did it right?
Yeah, that's what I got.
So what percent values fall between those 2 values? Or to the nearest percent, because that's 85%, or 86%, 86%, 86% of the values fall there. That makes sense? Using Chebyshev's, using that 1 over 1 minus k squared. Okay. I think we covered a lot of this when we did
Last
last year we did statistics, right? We did Chebyshev's, we did empirical. But I don't know if we got into, is there any questions on this one? I don't know if we got into the part of the next topic, which was z-scores, percentiles, quartiles, and
We got the
outliers.
I
quartiles.
remember Z-score.
Yeah.
We got the percentiles and quartiles, that was it.
Okay, z-scores?
We did? Oh.
Yeah.
Z-score, okay, what is z-score? Z-score, if you remember z-score, the higher the z-score, the better you did on the test. It's kind of like the z-score was, if you're comparing two, if you know the average of the class in the math test was a 58, and with the standard deviation of 6, and you know the English test was a 95, the standard deviation of 8, and you had a score, which test did you do better on compared to the rest of the class? You might say percentage-wise, you might get better on one, but compared to the rest of the group, which one you did better? And that's where we use Z-scores. When you look at a Z-score, it kind of goes back to that bell-shaped curve, and this kind of percentile does too. When you look at a Z-score, if I think about it, a Z-score right in the middle here is a Z-score of 0. And then you go to the right, it's always Z-scores are positive, 1, 2, 3, 4, 5, and you do the other side would be negative. This is like if you're right at a Z-score of 0, that means 50% of you did better than you and 50% did worse than you. That's kind of how the Z-score works. Okay? So we're going to kind of walk through some of the Z-score. The Z-score formula is nothing really hard or standard score. You use this in a state test sometimes as you go. Z-score is x minus x bar, your value, whatever you got, minus your average divided by your standard deviation. Both are the same. One deals with population, one deals with sample. A Z-score represents the number of standard deviations that value is above or below the mean. So when I get a Z-score of 2, that means I'm 2 standard deviations above the mean. The mean being the middle. So as you go through here, x minus x bar, nothing real hard here to do the formula. As you go, I think they have a problem right here.
So Z-score is just variance.
Oh, kind of, not really. It's kind of like standard deviation, but we kind of range it. Don't look at the answer here. I'm going to cover it up here real quick. There we go. A student scored 65 on a calc test that had a mean of 50 and a standard deviation of 10. She scored a 30 on the history test with a mean of 25 and a standard deviation of 5. Compare her relative positions on the 2 tests. So if you took the calc test, for example, and let's just say we said 65 on the calc test, and the mean was 50, standard deviation of 10. What we're going to do is to figure out her Z-score on the calc test. We're going to take her score minus the mean, which is 50, divided by her standard deviation of 10. That's going to get her Z-score, which is like 15 divided by 10, which is 1.5. She's 1.5 standard deviations above the mean. Now, for the Z-score of the other test, it says she scored 30 on her history test with a mean of 25 and a standard deviation of 5. So we take 30 minus 25 divided by 5, which is 5 over 5, which is a Z-score of 1. Now, if you look at the 2 tests, 25 out of 30, on the top of my head, the percentage, that's a pretty good percent, right? That's about 85%. A 50 out of 65 is in the 70%. Grade-wise, percentage-wise, she did worse in this test. Okay? Compared to the rest of the class, she did better on this test.
But you don't know that it was out of 100 on each test, though.
It doesn't matter. This deals with that. This deals with compared to the rest of the class.
Oh.
So if you went through here, now if you think about this, how this works here is this. Here's your Z-score is 0. Here's 1.5. Here's 1. Always the Z-score farther to the right is a better score. So like 1.5 is further right, we're good. We're in good shape. It's, she's relative higher in the calc class. That makes sense? How the Z-score works. Now percentiles, I don't use it a lot, but just to kind of know how to do percentiles. Percentiles separate the data into groups of 100 equal parts. You know, 100 percentile. 100%. A percentile rank of a datum, a data value, represents the percentage of data values below that datum values. This is going to get hard. If I have a set of data values, to figure out the number percentile of that data value, what you do is you say, okay, the number of values below x, below the value you have, add 0.5 to it, and divide by the total number of values. Then times it by 100%. And we'll try both of these in a little bit. So, for example, and you probably have an example here. Well, that's a graph one. We should do that too. Okay, let's look at this order. Okay? It says here, a teacher gives a 20-point test to 10 students, find the percentile rank of the score of 12. So the first thing you're gonna have to do is put the numbers in order. So we put the orders 2, 3, 5, 6, 8, 10, 12, 15, 18, and 20. If I wanna figure out the percentile of this value, right here, what we're gonna do is percentile, I'm gonna abbreviate, percentile is equal to the number of values below. If you look down here, they voted out, the number of values below is 6. So we're gonna take 6 plus 0.5, every times 0.5, divided by how many values there are? 10 values. Add them together, divide it out, we get 6.5 divided by 10. So that value would be at the 65th percentile. Small examples are hard to use. To do that. When you do this percentile, it's very hard to come up with what percent everything is. 65 percentile, 10 values. Usually when we get into percentiles, we start dealing with hundreds and thousands of values to see what percentile you are. The 6 represents the number of values that are below this value. So if I wanted, let's say I wanted to know what percentile 18 was. Okay? How many values are below 18? 8 of them. So I would have that percentile would be 8 plus 0.5 divided by 10. So on that one, it would be the 85th percentile. That's an easy example because it did it by 10 numbers. But if you had like 15 numbers or 12 numbers, it would be a little different. Okay? So percents, that's your percentile. Okay, and then it has another problem here. Okay, go through deciles. Deciles is separating your table. I'm not going to get into a lot of this right now. Deciles is separating your data set into groups of 10. Decile 1 is your 10 percentile. Decile 2 is your 20 percentile. Decile 3 is your 30 percentile, and so on.
Great continuous.
Quartiles are separating your values into 25ths, or you should know them before. Quartile 1 is your median of your lower to high. Quartile 2 is your median. Quartile 3 is your 75th percentile. This is one we didn't use a lot before. Interquartile range. The interquartile range is quartile 3 minus quartile 1. You will use that in a second to do how to figure out outliers. So make sure you know interquartile range is quartile 3 minus quartile 1. Remember with quartiles too, one of the things it doesn't say up here, you have to put your values in order, lowest to highest, and then go like from both ends to figure out your median, right? And then start from there and go from the other side too. So you cannot just take your set of data values and just start and go. You have to have them in order. And let's go back to that. We know how to do that. This is the formula I was telling you about before, measures the position, the outlier. An outlier is extremely high or low data value when compared to the rest of the data values. A data value less than quartile 1 minus 1.5 my interquartile range, or quartile 1, no, that's not right. Quartile 3 plus 1.5 interquartile range can be considered an outlier. So in other words, if I find my quartiles 1 and 3, and I take 1.5 times my interquartile range and add it to those values and subtract it, if my data value is outside of those values, that's considered an outlier. It has to be outside those values. 1.5 interquartile range. Now, I think we have a problem like this in practice. Let's see here. Maybe not. That's box English. Okay, let's go back. Let's find one in your quartile range. Let's go in your books. let's do the page 146, number 3. Okay, 136, page 146, number 38. First thing I want you to do is put the numbers in order. Okay, throw in order, right? Find your median. Right, 18.5, right in the middle. Find your first quartile. And find your third quartile. Okay. Now my inner quartile range, IQR, is quartile 3 minus quartile 1. So 20.5 minus 16.5, which is 4. Now, if I take that times, now the rule says times it by 1.5, I'm going to get 6. Am I following? 1.5 times that is 6. Now, what I'm going to do is I'm going to take this 6 and add it to my third quartile, plus 6, and I'm going to take quartile 1 and subtract 6. I just lost my book. So if I take quartile 1 and subtract 6, I'm going to get 10.5. Quartile 3 and add 6, I'm going to get 26.5. 10.5 to 26.5 is normal values. Now, if there's any value that does not fit in that range of values, that's considered an outlier. So on this set of data, 3 would be considered an outlier.
Well, just looking at it, couldn't we almost tell that?
But sometimes it's close. Now, if I had a value like here, maybe I would have 10.2 as one of my values. It doesn't look that far off, but 10.2 would be considered an outlier. That's kind of why I said this 3 is obvious, but sometimes it won't be as obvious as you think. That makes sense.
Like we,
Okay, last thing in this chapter, now let's carry case. How many member boxing was pretty easy. Minimum, quartile 1, quartile 2, median, quartile 3, and max, right? All those. That's the 5-number summary too at the same time. 5-number summary is the forms going through there. So what I'd like to, I'm going to stop there. The 5-number summary is the last thing, and I don't want to start chapter 4 yet. What I want you to do is work on this. When we get, if you have time. We got English paper due?
Yeah.
not us.
When's the English due, Monday?
Over there.
Yeah, here. We're not having school on Mondays. We don't do it.
Yes.
Take it with a grain of salt.
So those 2 Monday, you still have to hand it in?
No, it's peer day.
Okay. So, spend a little time doing that.
Yeah.
Monday, what I like to do is I'm going to do a summary of the chapter, these last few parts here, and then I'll spend some time answering as many questions as I can Monday, if you have anything on that. The part that most people have trouble with is test. This first part, mean, median, mode, and standard deviation is not too bad usually. When we put it together with chapter 4, which is probability and accounting rules, people have trouble with probability. There's a lot more walls than we talked about back in high school. So that's going to take a little more time. So I want you to be ready, done with chapter 3 before we start chapter 4.
Are we taking a test on chapter 3 by itself?
No, we get 4 together. So that's kinda why I said, we wanna make sure you got 3 done. I figured 3 is gonna be the easy part, you know, and then 4 will be a little harder, so that's kinda where, make sure you try to get 3 done as much as you can. Good? Like I said, all year, I'll keep working with you, I know you got English coming up, and I know, actually, this semester shouldn't be too bad, I got less college class, it looks like college.
We try to get
Yeah, but some of us still have three.
And some have biology. Second semester I heard it's easy.
Yeah, we have, plus, I don't know, we haven't really done much.
So, any other college life, those, Tony?
No, that was just last semester.
So that's done. Senior privileges?
I gotta
I would-
present those
Yes,
on Monday.
please.
Yeah, so,
You are? You just go up there and say, we want you.
Well,
I'm sure I
you
had a
request them,
sheet
you don't just say we want them.
Of basic senior privileges that we already have, you know, like the ones they do every year.
I'm gonna ask
No, I just have to hand it
I'm
out.
gonna ask one more.
and you're gonna ask,
Could you ask them that we can get it right now?
He's like, you can't, longer period of time. They won't do it.
Ask
they ain't gonna.
us.
Yeah, we're not a bad grade.
Be late for first hour.
Yeah.
Yeah. Oh, that would be
No,
great.
that would
No,
everybody would do
because,
that.
yeah, and you would die.
Well, most people do it anyway.
Yeah, but they get punished for it.
Yeah. There ain't much you can do. I think fourth quarter of senior privilege is about all you can get, right?
Yeah,
Maybe a week
and what it
early.
is you can
You know what ours?
leave during study hall and,
Which is my 7th-hour class. Sweet.
The other thing I wanted to, I mean, the reason I'm going a little bit faster too is because once fourth quarter starts and you do have senior privileges, it kind of, people
Peters out.
vacate fast. And so productivity is less fourth quarter than any quarter of the year
and
for seniors. So,
No,
So-
but you already have your class rankings.
Yeah.
So it doesn't count.
well, it does on your final transcript
No,
of the
they
column.
just don't forget. Yeah, but you're already in college.
All of a sudden they just.
but your college GPA, it does count.
Yeah, your GPA does.
Oh, yeah.
It doesn't count for your class ranking, but it does count for your college.
See, our school is a little different. You have your class ranking by end of third quarter. Because at Graceville, they don't tell who the valedictorian is until that Friday before graduation.
So they have like 2 days to write their speech.
Yeah.
Yeah.
They don't. They notify them then. So.
You're in the top of the class or not.
But that's about it. But they don't tell you until like that Friday or Thursday, something like that. And they calculate the ranks of fourth quarter and everything.
Yeah,
Oh, they should.
they actually probably should in Wheaton too. What?
It's pretty close for you guys though.
Yeah.
Did it change much on the first semester?
No idea.
A little problem.
Just little.
How are you supposed to figure out the
They
range
like
of
did
this
have the ranking for
when you
first
don't have
semester.
the?
They probably do now.
Okay.
Yeah, they do now, but like before they don't have it. Cause I didn't have it for something.
Well, top 10 are all from like point
I know they will. I think I'm ranked 11.
I have no idea.
You guys are you guys still tackle first? I don't think so, probably.
I don't know.
It should say your rankings now if you look at your report card, doesn't it?
Yeah,
Online?
well, your transcript is on. Not your
Transcript
memo.
was
Just my report.
Oh, I have like 12 of those to
Jessica
send
has
in for
nothing but
things.
8, none of them
I
any
remember.
minus, and mine's like B.
Mine's just
Don't you
nice.
hate being compared to your younger siblings?
Yeah, especially- It's like my report card can go